Good afternoon, everyone. Thanks for joining in today. Myself, Sunita. I work as Director of Engineering of Quality team at Hortonworks. Ask me anything about platform certification, anything for all of the HTTP stack. Primarily, my focus has been around Ambari for the last several years, and lately I've also taken up the core platform as well as security and governance teams. Very glad to be part of the team, and today I'm going to share some insights into what is the challenges we face to certify the whole stack, tips on how we brought in some efficiencies around testing the complex stack, and I hope you can carry away some of those. How many of you are into quality engineering? Okay. How many of you have visited a zoo? All right, pretty much everyone. So we do have some crowd who actually is part of the quality engineering. I call it quality for the Hadoop Zoo because a lot of the components, as you guys know, well, we always call the elephants representation for Hadoop, right? And you also have noticed a lot of component names being named along with the animals as such. Without further ado, quickly on the agenda, first we are going to look at the entire Hadoop stack briefly, just so that we have an understanding of what I'm speaking about, what is that we are going to test. We'll also look at the test certification matrix, various stages. I'll speak about the journey, how it starts right from where a developer puts in a commit into Apache, and how we take it to GA and ship the platform as such. What can possibly break? How many of you are actually developers in Apache? Okay, I think from a developer's perspective, we always think that, oh, what could break? I think I have done my testing, I commit this code, and it'll all be good. That's the confidence most of the developers have, right? I'm going to talk about what can possibly break, and how do we actually try to break the system here, and the challenges we face along the way, and some of the solutions we have put internally at Hortonworks as such. So let's look at the Hortonworks data platform. This is the, I think a bunch of you have already seen the hybrid architecture. Briefly looking at the stack, these are the number of components. If you count carefully, we are looking at almost greater than 25 components here. On the rightmost side, you're actually seeing operations and orchestration, which is Ambari and Cloudbreak, right, which is primarily used to bring up clusters, manage the clusters on-prem and on the cloud. And on the left, you're looking at security and governance systems, which consists of Ranger and Atlas, primarily to ensure that there is compliance and integrity within the clusters. And you're also looking at various streaming, machine learning components. So all of this actually forms the entire Hadoop ecosystem. And imagine if you have to test individual of them, and you have to test the entire ecosystem as a single stack. As if that wasn't enough, we also think about, hey, now that I'm preparing the system, or I've prepared the system, how are my customers going to use these, right? They're all going to have different platforms, different operating systems. They'll have different requirements to have different databases. Individual DBAs may have a preference. They have hosted their own databases. They might be using different JDK versions. So we'll switch over to the next slide here, which actually shows all the different combinations which make up the matrix, right? If you look at OSs and databases and JDKs is what I spoke about. Not just that, right? I mean, we're also talking about various file systems. Plus, you may want to have Kerberos enabled. Some companies go and say, hey, can I also enable encryption as such? So looking at all of this, if you actually combine, try to certify on every single platform of this, you will end up into clearly about 30,000 combinations, right? So that's a lot. And For the amount of commits which come in from Apache, and the number of components we have multiplied by these, the complexity itself to certify the stack can be ever-ending, and we definitely do this on a sequential basis, right? So we had to put some thought into how do we do this in an efficient way, yet not lose as much coverage. So which brings us to the point of how do we break this down, right? Here's how a typical release looks like for us. All the upstream, on the right when you see upstream releases, individual projects on Apache have the release cycles, independent release cycles. And we bring in all the commits from Apache. As you guys know, Hortonworks is all open source. So everything which we do comes from open source repositories. So we ingest code from the open source repositories into the internal repositories. And as a process of this, the very first stage, right, we want to make sure that, hey, I'm not bringing in some broken code. We all know that there is some unit testing capabilities on some of the Apache projects, but we want to enhance that, and we run additional unit tests as part, as well as smoke tests, as and when we bring in any commit from Apache into our internal systems. So that's our very first stage. To us, it's almost looks like pre-commit. It's not really pre-commit, but before it comes to the internal repos, there is some kind of validation which gets into, is in place. So the next one you see there is, of course, we have to package all of this and form the single stack, which is shippable as a single entity. And once the stack is built, we now need to run what we call as nightly automated tests. We could, of course, run them more frequently. We do run some of the tests, what we call as promotion tests, which runs throughout the day as an additional gate after the integrated platform is available, so that we can make sure that before I consume these builds into the nightlies, I'm not getting into another surprise, which is absolutely an integration failure, right? So we do run those promotion jobs in between, and we consider them as blessed builds so that they can be consumed for a fully nightly automated approach. We'll deep dive into the nightly automated tests a little bit later. We do have different kinds of tests in the nightly automation framework. We also have pre-prod tests and long-running readiness clusters. Pretty much these fall in towards the end of the release, where we upgrade or we host clusters on an internal network. And just like how the customers would actually upgrade their production clusters, we do upgrade these readiness clusters. And the readiness clusters mimic a lot of the user workflows, which gives us, which helps us catching in issues at scale, right? So these are actually running at scale. And we upgrade our clusters and make sure that the new versions which are going out the door don't have any regressions and are ready for our customers. So coming to the point of what can possibly break, right? This is where I want to talk about different kinds of tests we do and what we have seen, right? Functional regressions, and what I mean by this is we have shipped many releases, and from release to release, there is new code coming in. And for example, you already have, these are just examples of features, right? We shipped config groups, we have lineage and atlas, scheduling and yarn, so on and so forth, right? So there's existing features on the stack, which we want to make sure that these are not broken as and when the new code is coming in. And there's always new features for every Apache release which comes out. You guys have all seen what's coming up in 3.0, right? The GPU and various features which are coming on 3.0. We want to make sure that, hey, the existing ones are not broken in terms of functionality or performance, any kind of regressions in terms of, which could potentially affect our customers. So just to give you numbers on these, we have closely about 30,000 tests, just in terms of functional, and we also have fault-tolerant tests. An example is killing an agent, or if a node manager fails, what happens in terms of recovery within yarn, right? So these are the different kinds of tests for functional regressions. Reliability. So we all know Hadoop itself actually supports HA, but when we claim support for it, do we test it enough? Do we make sure that, do I bring down one of my name nodes and actually test failover happens, right? So we do have a set of tests which purely perform failover and validate that a true failover is actually happening. What I've stated there is just an example how we get the active name node, suspend one of the processes, and check that HA actually kicks in. Similarly, all the rest of the projects do support HA. We do similar kind of testing with HA as such. As if that was not enough, more and more customers are actually moving towards all HA, which means none of their clusters are non-HA, right? We all want high availability all the time, which is why we run all the battery of our tests on completely HA-enabled clusters, which not only guarantees that the failover happens, but it also guarantees that functionally there are no differences when you are on a HA-enabled cluster versus non-HA-enabled clusters. Plus, it also gives us the leverage that, hey, no infrastructure is up and running all the time, right? We also, maybe there is a failover which naturally occurs, and we also have this fault injection tests. So when that happens, we are actually validating that there is HA which is coming into the play. Just a sample of the long-running workflows. This is what I was earlier mentioning about the readiness clusters. These are just examples. And what we have noticed, for example, I know a lot of you may be familiar with TPCDS and TPCH for actually benchmarking, right, and industry standards. But for us, we actually found different kinds of issues. We run this at scale. We run these queries at with about 1 terabyte of data. And because of doing that, when we released LLAP, we found a lot more issues internally, which would otherwise have hit our customers, like things like memory leaks, right, and containers getting killed. So these are the kind of issues you actually find which you don't find with the short-lived clusters. And pretty much when we run the tests on nightly, as you can all imagine, they usually run overnight and they are killed, right? So we have very short-lived clusters. So which is why long-running clusters play an important role for us, where the workflows are running for several weeks, and you get to see issues as much like what a customer would see on their environments. Okay, so all done. I think we all finish functional testing, HA. We also think that, okay, these long readiness clusters are also going on in parallel, right? Typically what happens after the release, right? The customer gets ready to upgrade, and they look at all the features and say, hey, which version should I use? Based on all the documentation, based on what they have seen, they want to upgrade, right? Can we guarantee that an upgrade works? Because there is code changes. We may not be able to guarantee that, right, unless I have tested it. And look at the various kind of upgrades we even support. First of all, we have a platform to manage the clusters, right? So that product itself needs an upgrade now because you are tightly coupled with the stack, and you actually want to, when you want to upgrade to the newer stack, you also want to have different configuration changes applied to your newer stack, which is where Ambari kicks in. And this has added great support for automated upgrades. Otherwise, you can imagine the nightmare of trying to upgrade the clusters manually, migrating all of your workloads. So Ambari has added support. The first one where we are, which was out there was rolling upgrades and downgrades. And eventually we also added support for express upgrades, which is also called as stop the world upgrade and faster. And early this year, we also announced patch upgrades, wherein you can get upgrade only specific components within the stack without having to upgrade all of your stack. So again, we have been shipping this from several years, right? You can imagine how many number of versions are out there. And being part of the QE, it's our responsibility to make sure that regardless of which version of the stack or Ambari our customers are on, we guarantee that the upgrade will actually work. So which means, again, we run into the same challenge, the combination monster. So we have literally maybe 20 to 30 versions and going up into the current version, along with the other platform matrix we talked about, right? Some clusters may be encrypted, some clusters may be just Ranger enabled, right? Some clusters may be unsecure. Plus some of the clusters may not have Spark, right? So there is different kinds of combinations, even in terms of what services within the stack you're actually utilizing based on the use case. So that leads to n number of combinations again. And what we have done here to address that challenge is we've actually taken real data. Every cluster upgrade, which is done by our customers, we collect information of which version people are going from. And we've come up with a matrix which actually comes up, takes care of upgrading from the most popular versions. And we focus most of our testing on the most popular versions, and then maybe like smaller amount of testing on the versions which are almost retiring and which we have seen that customers are no longer on those older versions. So we kind of, it's an iterative process. We go back frequently and then update our metrics as such. And just the upgrade wouldn't be enough, right? I will, if you can imagine, I'll bring up clusters which may be of HTTP 2.6, and then I will just use the automated upgrade within Ambari, and I can automate all of this process, right? Going through an upgrade. And after the upgrade, the cluster looks all green. That wouldn't be enough to catch all the issues, right? What we really want to validate is, hey, if a rolling upgrade is supported, what is the expectation from our customers? Customers expect that all of their workflows which are actually running are not impacted, right? That's the expectation, and we want to mimic this on our test platform as such, which is why I've written an example here of launch and a long-running application, right? And it doesn't have to be a complex long-running workflow as such. You can take anything simple as a word count or keep repeating that. And as the upgrade goes through, you still validate that, hey, these jobs are actually not impacted. And at the end of the upgrade, we validate that none of the applications got killed because the version switched or anything like that, right? We also want to make sure that the upgrade itself is fault tolerant. In the initial stages of releasing rolling upgrade itself, I think we encountered a lot of issues in terms of fault injection. Happy path scenarios were not good enough, right? And especially this happens most of the time. Actually, there is no happy upgrade, I think, at any of the customers, right? You can imagine upgrading simple software itself does not go smooth most of the times. And with the complex stack, it's obviously expected to have some or the other issues. Which is why we have invested a lot of time into fault tolerance tests within upgrades, where we actually make sure, just one example is, Ambari has a feature where even if the slaves are actually lost, the slave host, like maybe the agents are killed, right? You want to make sure the upgrade itself is not hindered. You provide options to customers to put some of these into maintenance mode, move on with the upgrade. So several scenarios like that. What happens if one of my host goes on, which is actually having a master, right? Is it fault tolerant enough? The product itself is fault tolerant enough. So we have tests to capture all of that. Similarly, post-upgrade, we want to make sure that all of the components of the stack are actually functional. So we do run the earlier tests which I talked about, all the functional tests. We do make sure and validate that post-upgrade, the entire stack is still functional. So we talked a lot about what could break, what are the different kinds of tests we have, and the number of tests we have. And we also talked about the platform matrix, right? Now, what is the challenge we face? If you were developing a product within an organization, you have a lot more control on how you ingest code and what features you're working on. But being completely open source, the first point I note here is ingestion from open source, where there is a lot more developers from the community, and we actually, in some cases, we cannot actually control quality there, right? So quality is best. It's not an afterthought. It has to come as you develop code. And one of the challenges I clearly see is, hey, the commits are already there. If the commit is already there, the damage is already done, right? If you have not tested it enough. So that's one of the challenges. And of course, the compute. So imagine testing all of these components and the stack together, the upgrades, and all of these with the churning code every single day, right? So we have commits every single day. I think probably about 100 I have seen on an average every single day just for HTTP 3.0. I'm not even talking about all the other platforms, right? So having that clearly calls out a necessity of compute, because we have to bring up all of these clusters which we need, real integration clusters where we can run our tests, right? These are all integration tests to me, where you have to bring up, hey, I want a cluster which has, which has Spark. I may also want to have a different cluster where I want to run my queries, right, on the EDW clusters. So various kinds of clusters, various kinds of combinations with the platform, which clearly calls for, you can imagine how many number of machines we really need to bring up these short-lived clusters. Which is where I want to talk a little bit about how we use Yarn on Yarn. I think earlier at the summit, Billy spoke about this in detail. Just touch basing on that. So if our customers are able to use Yarn for all of their scheduling needs, we thought, hey, why not dog food and use the same within our internal infrastructure as such, right? And we've been successfully able to do that. We moved off of OpenStack a couple of years back. We migrated all of our workloads from OpenStack into what we call as yCloud. And if you look deeply enough, so the real combination here is we're using some core components within the stack combined with the Docker itself. And there is every cluster itself, every Hadoop cluster, if you look deep enough, there is again one more Hadoop cluster within inside of that, right? So that actually helped us address compute needs internally in our internal infrastructure. And the other challenge we actually face is failure analysis, right? As much as you want to write new tests, you must have heard this before. One of the reasons why we end up with bugs at customer sites, like once the product ships, is either you don't have enough coverage, or you've actually automated, you have enough coverage, but hey, you're not executing all of them, right? Or you have executed all of them, there have been failures, but nobody has ever looked into these failures, right? So This leads into the third challenge, which I'm talking about, failure analysis. And what comes to our rescue there is Log AI. I encourage you all to go look at our blogs, which speaks a lot more into detail on how we have used something we call as a smart analysis of the failures, which essentially looks through all the exceptions which come across from all the failures for specific build or maybe for previous builds, and tries to correlate failures and says that, hey, the same exception has occurred across the stack, across all of your test results. Maybe this is the same issue you can actually utilize for. Of course, nothing is completely humanless. You all must have attended the talk on AI, how without human notice, right, AI can go wrong, right? So the prediction in 2015 about a snowstorm, if there was one human looking at all of those models, clearly there was an indication that, which Kevin actually clearly showed at the keynotes, that, hey, there's still some human intervention which is of value. But is AI not useful? It is definitely useful. Otherwise, it will be a nightmare for all of us to actually look at thousands of failures on any single given day. We also use something called a smart certify. And what I mean by that is, with so many commits coming in, there's always some of the components which may have not changed, right? Or maybe within the product, you may not have done anything, like your commit is completely unrelated to upgrades. So why run all of the upgrades with all of the combinations if the code has not changed? So we thought about it, and the most efficient way for us to look at this was to only pick up components which have actually changed. That was our first step. And run tests which are applicable to those components, plus any of the components which integrate with it, right? For example, if HDFS has changed, I definitely want to run all of my test cases which I have for HDFS, right? I want to run including HA as such. And I also want to run anything which integrates with HDFS, tightly coupled with HDFS, right? For example, I want to run something with Ranger as well because of the policies, right? Similarly, if I was changing Ambari code, that's where if I am seeing commits on, there is specifically upgrade catalogs. So we watch for code changes which come into those files. And we have automated the system where we see that, hey, the upgrade catalog has changed, and let me now run all of the upgrade tests to make sure that there is no regression. This has actually led to a lot of savings on the compute. Definitely, if there are too many commits coming in, if the churn is quite a bit, we won't be able to catch all of the regressions, right? Sometimes we could always go wrong with coverage-based testing as such, which is why we actually make sure that, hey, once in a week, definitely make sure to run the full battery of the test, and rest of the time, be a lot more efficient in terms of how we use the compute, how we use our human resources to look at the failures, and so that we can focus more and more on adding new features and validating the newer features. With that, we actually come to an end. I want to leave some time for questions.
Do you have any testing framework for application development on this Hadoop? Like, you covered everything on like how do you test the platform itself?
Right.
Like, are you guys developing any framework to test the application or script developed on top of?
Right. Right. Yeah. So I didn't touch base on that. So we do have test frameworks for, as you know, each of these are in different Apache projects. So some of the components use JUnit test framework, JUnit/test engine in some cases. And we also use PyTest because we wanted to make sure, like, one of the requirements was also to have, originally when we took all of these tests from Apache, we wanted to a lot of them historically were based on shell, right? We wanted to certify this on be be able to certify this on the Azure platforms or Windows platforms back when we started. So primarily the choice was to go towards Python, and hence PyTest is actually the largest, most popular, I can say, within the organization. And the next one I can say think about is the TestNG framework as such. We use the features which are provided by the frameworks themselves, plus we actually have integrations into external tools. If you want to do reporting and stuff, so there is APIs. And as much as possible, we use inbuilt features within the framework itself.
Do you maintain any guidelines for your partner certification, or like if somebody comes and claims, hey, our product is certified in ISTP 2.6 or 3.0, what are those guidelines?
You want to know the guidelines for partner certification,
Yeah.
or? Yeah, I think we have something called as QATS. So there we have guidelines on what are the prerequisites, what tests, which test cases will be actually run. QATS actually supports running the battery subset of the tests on any of the partner environments, right? And we do provide a full guideline document on, hey, these are the prerequisites which need to be met in order for you to actually be able to run these tests. So I encourage you to, Gerge is here. He actually heads the partner certification team. We'll be happy to connect with you afterwards and show you those guidelines as such, give you pointers at least. Yeah. All right. I hope you enjoyed the session. Thanks for joining.